All right. Hey, everybody. This is Miss Turk. I'm here to explain some stuff about Unit 3 that I don't think the text explained very well. This video does not go with a particular assignment. It just kind of goes with the beginning of Unit 3, and I think it'll clear up some stuff about electron configurations. So before we dive into what the textbook says, I want you to think back to your past science classes when you've learned about atoms and electrons that are in energy levels, and see if you can remember how many electrons can fit in each energy level. You might have seen a Bohr model of the atom. The energy levels don't actually look like this, but the Bohr model has the energy levels drawn as circles, so we can kind of easily see the energy levels, and we can put dots in them representing electrons in the energy levels. So see if you can remember how many electrons go in each level. Maybe you learned it in middle school science. All right, so you may remember that the first energy level can hold 2 electrons. Okay, so those go in the area in the energy level closest to the nucleus. The second energy level can hold 8 electrons. So I'm going to go ahead and fill in the second energy level with 8 electrons. The third energy level, you may have learned that it can hold 8. It can actually hold 18. And the fourth energy level can hold 32. Okay. And then there's, the energy levels get bigger after that. But we're going to focus on the first 4 levels. Okay. What you have not learned before is that in each of these energy levels, they are broken up into sublevels. And then the sublevels are broken up into something called orbitals. Okay. So the first energy level only has one sublevel, and the sublevels, they give them letters. So the first energy level has a sublevel called S, and S sublevels only have one orbital. Okay, an orbital is a region where electrons are likely to be found. Orbitals have all different shapes. They are not circles. I know that they appear to be, it sounds like a circular word. Sometimes we draw energy levels like they're circles, so people tend to think circles. They're not circles. They're variously shaped 3-dimensional regions where you're likely to find electrons. If it's an S sublevel, there's only one orbital, okay? And we represent with orbitals as boxes. They're not actually box-shaped, but we represent them as boxes. And then instead of representing the electrons as dots, we represent them as arrows. And 2 electrons can fit in each orbital. So draw 1 arrow going up and 1 arrow going down, okay? The direction of the arrow represents something called spin, which is not literal spin. It's kind of beyond the scope of high school chemistry. But in any case, the first energy level has an S sublevel, it has 1 orbital, and it can hold 2 electrons total. E minus stands for electrons, okay? The second energy level is bigger, okay? It has 2 sublevels. It has an S and a P. S sublevels have 1 orbital. P sublevels are bigger. They have 3 orbitals, okay? So this can hold 2 electrons, and this can hold 6 for a total of 8 electrons. So the 8 electrons that are in the second energy level, 2 of them are in 2s, and 6 of them are in 2p, okay? So second energy level, S sublevel, we call it 2s. Second energy level, P sublevel, we call it 2p. This is 2s, and this was 1s up here, okay? Third energy level is even bigger, okay? We're getting further from the nucleus. It has an S sublevel, a P sublevel, and a D sublevel, okay? S has 1 orbital, P has 3 orbitals, and D has 5 orbitals. Okay, so if we put electrons in all those orbitals, sometimes we just draw the arrows as like a half arrow up, a half arrow down, just to make it quicker, because we get so sick of drawing arrows, okay? So that's 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons total in the third energy level. Okay, this is 3s, this is 3p, and this is 3d. Fourth energy level is even bigger. Has an S sublevel, a P sublevel, a D sublevel, and an F sublevel. Okay? S has 1 orbital, P has 3 orbitals, D has 5 orbitals, and F, if you guessed it, 1, 3, 5, 7. Okay? F sublevels have 7 orbitals. So if we were to fill these with electrons, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 30, 31, 32. Total of 32 electrons in the fourth energy level. Okay. So this is for S, this is for P, this is for D, and this is for F. Oops. Okay. Those are the names of the different sublevels. So this is the energy level, and then these are the sublevels, and each box represents an orbital. Okay. It would be great if the electrons actually filled in this order. So if you started in the first energy level and you did 1s, then you went to the second level and you did 2s and 2p, and then 3s, 3p, 3d, and then 4s, 4p, 4d, 4f, but it doesn't work that way, okay? The reason is there's parts of the fourth level that are lower energy than parts of the third level, and things get even more out of order the further you get from the nucleus. So things start out in order. So I'm going to write down the filling order. We start with 1s, and then we go to 2s, 2p, 3s, 3p. Then we jump to 4s, then we go back to 3d, okay? Then we go back up to 4p, and then actually after 4p we go into the fifth energy level, which we didn't even talk about, 5s, okay? And then we go to 4d, 5p, and then we go to 6s, dot, dot, dot. Okay. You're not going to need to go beyond here, I don't think. Actually, you might not even, I don't know. Don't worry about anything after here, okay? Things start to fill completely out of order. You'll put electrons in the seventh energy level, then you'll go back to the fifth energy level. You're not going to have to go that far, okay? So just so you know, things fill out of order. And the way that your book represented this was on this page. Okay, so you can see the first, second, third, and fourth energy level split up into sublevels. And you can see it goes 1s, 2s, 2p, 3s, 3p, 4s, then 3d, and then 4p, 5s. If they had the fifth energy level, 5s would actually be coming in right here, but they didn't go that far. So in any case, you can kind of get a sense of the order there. All right. And when we write out the electron configuration, we put a superscript, which is a up high number, to say how many electrons are in that sublevel, okay? So 1s, if we go with this electron configuration, 1s has 2 electrons, 2s has 2 electrons, 2p has 6 electrons, 3s has 2, etc., okay? Let's say we were dealing with an element that only had 13 electrons total, okay? So we had 2 here, 6 here, 2 here for a total of 12, and then we would only put 1 arrow in 3p and we would be done, okay? So it would end in 3p1, okay? And then we would just stop there. So all the little numbers, the little superscripts, add up to the total number of electrons, okay? So you just work your way through the filling order and add in electrons, and then that will show you the arrangement of the electrons in the sublevels. So because things don't fill in this order, the way your book kind of lays out the orbitals looks more like this, okay? So this represents 1s, this represents 2s, this is 2p, because it has 3 boxes, then this is 3s, 3p, and this is 3d. I kind of ran out of space, so I had to squeeze that in. And then 4s, 4p, 4d, and then there's going to be a 4f as well that I didn't have room for, but you're not going to have to go that high, okay? So when it asks you to show the electrons in their energy levels, in their sublevels, they might call it an orbital diagram or an energy level diagram. Just start with 1s, put 1 arrow up, 1 arrow down, okay? So let's say you were trying to do the electron configuration for potassium, okay? So potassium has 19 electrons total because its atomic number is 19. So we're just going to count our way up to 19. 1, 2, 3, 4, 5. Technically, you're within a sublevel. You should put 1 in each box before you double up. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then you need to remember, after 3p, we don't go to 3d, we could jump to 4s, okay? So after 3p, we go to 4s. And then if we had more electrons, we would go back to 3d. But we're not going to have more electrons. So that's 18 electrons, 19, and then we're done. Okay? So this is the diagram. And then if you wanted to write the electron configuration, we just turn this into shorthand. Okay? 1s2, 2s2, because it has 2 electrons, 2p6, 3s2, 3p6, 4s1, and that's it. Okay? So that's just a little explanation about where all these levels and sublevels come from and how they relate to the energy levels, in this type of atom model that you've learned in the past. All right, so I hope that's helpful.